Start the recording now.
Okay, so hello, my name's Qian. So I'm currently a first year UI/UC PhD student. Today I'm gonna to talk about the work I have done previously, like 1 year ago when I'm still in Tsinghua University. So the name is Tell Me More, towards implicit user intention understanding of language model-driven agents. Um, so a bit of background. So it's like I have been doing research on the tool learning and the agent sides for like almost like 2 years. So this work is mainly about like how to clarify the user intent during the user agent interaction. So previously, like when we are using very complex agent systems, we always find that the agent systems sometimes they won't exactly satisfy our needs. So even though it executes some tasks, and it says like I have finished that task, but not always like human are satisfied with it. So this work is mainly aims to tackle this kind of problem. And yeah, so this work is also uh, admitted to the ACL 2024 main conference. Okay, so let's start. I'm going to divide this talk into several sections, including the introduction, benchmark, method, and experiments, and finally the conclusion. So first thing, uh, we can see that many current agent designs, they seldom consider like robust user interaction. So this means the user's initial instruction to the agent system usually is vague and brief. That means like when we human, we want an agent to do something. Before it really does it, sometimes we do not even know like what our specific requirements is. So this is why our users' initial instruction sometimes is vague. And the second point is like different users, they have different intentions, which necessitates like explicit query and inspiration. Um, this is another thing. Like for a task, the agent may have like many different methods to execute this task, but uh, different users like they may have different preferences. They may have like different intentions that necessitates explicit query of the agent in order to get the task done in the most like user satisfied way. And here is an example that's not about user preference, that's about like missing information in the agent task, like locate the best yoga class in my city. So if the user just talk about this task to an agent, the agent definitely do not know like, oh, what is in my city? So where the user is, and also, what is the best, the criteria for the best? So the user said like best yoga class, but to different people, best means different things, like whether it's like top rating class, whether it's the class that is like most, the nearest to my home. So there are many different criterias, and all of these needs the explicit query to the user in order to get the answer and user preferences and intentions to better satisfy the user's need. Uh, so because of like these situation, we stress the importance of implicit intention understanding during the user agent interaction. Um, Here is a figure like a comparison of the agent execution workflow with implicit intention or explicit intention after the user agent interaction. So for a user, it may sometimes give a vague task first, and the agent system may leverage like different tools in order to execute that task directly, but sometimes this may not satisfy the user's need. So for the agent system, if it has the ability to explicitly understand the user's intent, so this kind of agent system will first ask the user what are their specific intention or preferences, and the user may like answer give some of them own answer, and then the agent system began to execute the task. And during the task execution, the user may still like ask progress, interrupt, and provide information. So all of these make a more robust user agent interaction system. Uh, yeah, so currently I'm going to give a very brief overview about like how we solve this problem. So uh, we see that current agent benchmarks, first they usually assume the clearance of the given task. That means uh like for the math tasks and for the QA tasks and like for tasks like in GAIA, some of the existing benchmarks, they are very clear on instructing what the agent should do or should find. Uh, so because of this benchmark, they lack the kind of vagueness of the user intention in it. So current language model, they're not tested on this kind of benchmark. So uh kind of like there's a gap between what our like user really needs the agent system to do and what the current benchmarks bench the agent's capability. So we introduce a new intention interaction benchmark which provides general agent task over like hundreds of categories. And the task also include like the vague task. So there are like missing details, and each detail's importance level and options are different. And uh, in this work, we also provide an innovative approach to evaluate present agent systems. So we divide the agent system evaluation into two stages. One is for the upstream. It involves instruction understanding, and also downstream, it involves instruction execution. So for most of the previous like agent systems, especially the task solving agent, they mostly focus on the instruction execution part. So that's how to faithfully carry out the execution of the user task, like invocating external tools and using their own internal reasoning. But very few work actually focus on the instruction understanding. So that means the agent have to first understand clearly what the user wants, and then to carry out the task. So this will reduce the kind of unnecessary things that the agent do and make the user more satisfied. And so here is our like the core research problem in this paper, how to enhance the interaction ability of the agent system through the underlying model's robust intention understanding. So we introduced the IN3 interaction, this data set in order to train the agent module. So we construct a simulated model user conversation record, and I will talk about like all of these in more details in the later sections. And also using this training data set, we kind of adapt the Mistral 7B. This is kind of an old model because this paper is done and released like last year. But like using our training data set, we can actually adapt to different kinds of models. So at that time, we adapt like Mistral model into Mistral Interact. So this is training on our created data set. So our trained model is able to judge the vagueness of user interaction, actively query for missing details with suggestions. So that's one of the most important trait of the agent, that is the proactivity. And also finally, the agent we adapt can explicitly summarize the detailed and clear user intentions. So here are some like evaluation results. So we divide our evaluation into two parts. One is the evaluation on the instruction understanding, that is how to let the agent clearly understand the user task. And next is that after understanding this task, how the agent carry out this task. So this is through the evaluation on instruction execution. Okay, so I will talk about these in more details from here. So in introduction is only a very brief overview. Okay, so the construction of the IN3 benchmark. So IN3 actually here means intention in interaction. So all the three words starts with IN, so we call this benchmark IN3. Um, we kind of construct this IN3 benchmark in a self-instruct way with like human written seed. like here an example for each data point. It belongs to a certain category like health advice, and we still use that previous example task locate the best yoga class in my city. So we first have all of these like human written seed task. So this task, they have like two most important traits. One is that they are agent task. So for an agent, they use like online searching tool, they use web browser, they can carry out this task. And the second trait is that um, this task all contains some part is vague. So like locate the best yoga class. So the user may have different preferences on what is the best. And also in my city, this is kind of the very necessary detail. The agent, if they do not know where is my city, the agent cannot carry out the task. So after the human written C task, we kind of do the data augmentation. So this is done in a self-instruct way. From the task pool, that is the seed task, we sample different task examples and leverage the large language model to generate more samples based on these demonstrations. And the generated new data points will be used to augment the task pool. So this is done in an iterative way. And finally, after we get all of these tasks, we conduct the human annotation on whether the task is vague or not. And if the task is vague, what are the missing details? What is the importance of each missing detail? And are there like some of the answer options for this specific detail? So the example we give here is like, so the user city, the criteria for the best, these are the two missing details of this task. But even though there are two missing details, they kind of are of different importance. We can see if the agent do not know where the user is, like the user says in my city. So if the agent do not know that, it definitely cannot find a class because the world is like really big. There are so many cities. So the agent will definitely we cannot call it like hallucinate, but its answer definitely cannot meet what the user really wants because it doesn't even know where the user is. So this kind of missing detail is what we call like indispensable missing detail. Without it, the agent definitely cannot carry out this task. So this kind of missing detail is more important. However, for the best yoga class, like the criteria for the best, um, without the user's preference data, the agent system can still carry out the task, even though the user are not like that satisfied. So this kind of missing detail we can see is kind of less important than those kind of indispensable missing detail. So that's how we divide the importance of different missing details. So all of this is done like during the human annotation, and this is the whole pipeline workflow, how we construct the data set of IN3. Here are some like statistics about this data set. So it involves like we actually divide the task into the training set and test set. So in the training set, there are like over 1,000 tasks that are annotated as vague, and there are also like clear tasks, which like if the agent meet these tasks, they can directly carry out the instruction instead of like asking the user question, always asking the user for missing details because some of the tasks they are clear, so the agent does not need to ask anything. And here is like how we divide the missing detail into different importance level. And for options, yeah, I forgot to introduce that actually. So let me get back a little bit. So options here actually means for each missing detail, what are some kind of expected answer from the user? So like where is the user city? So here we give like many big city names. So these are like potential options in order to inspire the user's answer, like what should the answer's format be, and what kind of like answer is the agent system expect from me. So with these options, the user will get like clearer on how to answer this question, and the user may be like more willing to answer this question. So here like uh we give like the average number of options in the IN3 dataset also. Okay, so after getting all of that, we conduct a preliminary test on the intention understanding ability of uh, language models. So we can see we kind of divide the we first give like 10 examples, randomly select from the IN3 dataset, and we ensure that they are all vague tasks. And we ask the model at that time. So at that time, like Llama 2 and Mistral, and also GPT-4 models. And so we can see the models, we tested two abilities quantitatively. One is that whether they can judge this task is vague or not. Another thing is that uh, what are some missing details? We ask the model to identify the missing details in these tasks. And on the right is the model's performance. And you can see it is not really good, like especially for the open source model. So GPT-4, it can get like 9 out of 10 correct, but for open source model like Llama 2 at that time, it only like gets 6 or 7. So uh, we kind of analyze the reason why they error during the judgment, and we divide into like um, three parts. So we analyze the error from three aspects. One is like during the judging, one is during the inquiring, and one is during the summarization. So uh, we can see the model, they kind of lack the ability at that time. So for especially for the open source model to accurately judge whether there is like missing detail in the user task. And also if we prompt the model to ask something like to clarify things and interact with the user. They sometimes ask too much without stopping, and even sometimes they will like ask too few questions and quickly jump to summarize like what is the user intent. They thought they clearly understand it, but it haven't done so. So, and during summarization, sometimes they solve task instead of provide summary that is not quite instruction following, and sometimes they provide assumed or hallucinated details. So these are some observations we get. So we summarize it into text in the three bullet point we show here. Like we want the model to make a more precise judgments of task vagueness, and we want the model actually to query more important missing details of diverse aspects in a more user-friendly way. And also, we want the model to summarize the user preferences comprehensively without omissions. So these are the three abilities we deem as the most important, like during from these three dimensions respectively, that we want the agent to be able to do to better and more robustly interact with the user. Okay, so here is a more detailed like case study about our preliminary study. So uh, I will maybe just talk about one example, like from the left. Um, find the latest research on the IB's treatment. So if we instruct the language model to directly ask the question, maybe it will say something like a research on what was specific type, and the user said like I would like to focus on type one. So the the agent sometimes they won't summarize the user intent, but they directly jump to give some search result. So but actually, we want the agent to do it later during the instruction execution phase. But here, the agent system directly began to hallucinate some result and leave it to some like hallucinated names like XYZ. So it doesn't make sense. And on the right, the example is like there are missing details in the summary, and sometimes when they are summarizing the human preferences, they still hallucinate. So that's the kind of problem we observe during the preliminary study, and our trained agent, we want to kind of solve this problem. So here comes to our method. Um, so previously we have constructed the IN3 tasks, but we haven't really constructed data points that can be used for training. So because we cannot just, it's like in a question answering task. Currently, we only have the question. We do not have the answer for that, so we cannot train the model. So for this task, currently we have the question, but what is missing now is the interaction record. So in order to train a model, we have to have both the task and also the user agent interaction trajectory for this task in order to successfully train the model. So here's like what we want in the conversation record that is also like the interaction trajectory. So we make some little tricks in constructing this interaction record. The first thing is the explicit initial thought. We want the agent to explicitly think about what the user needs and what are the missing details. And also, when we are constructing the conversation record, we actually construct the agent to query the user with proper options. That is like only one query with options in each round to guarantee that the user is willing like to answer this, and in order to make the interaction trained more user friendly. And also, we kind of from the user side simulate diverse user tones. That means the user sometimes they may answer the question in a passionate way, that is answering in a like very long form, give a very long form answer, but sometimes the user kind of just want to type in a few characters and answer it in a more succinct way. So we want our training data to encompass like all of these different scenarios and diverse user tones in order to let our train agent be more robust. And finally, is that our train agent, we let them to explicitly give a summary of the user intents at the very end of the conversation. So this summary actually is a clearer version of the user goal, and it will help the downstream agent to actually carry out this task. Okay, so here is a example. Let me illustrate it like still the previous example, locate the best yoga class in my city. For this task, it will first like we have done the annotation for this task, like the vagueness and what are the missing details and their importance. So we use these annotations to manually construct the assistant their explicit initial thought. Like the user task is vague, so its missing detail includes what things and what are some of the options for each missing detail. And with this missing detail, uh, we let the agent uh, to query with options like where do you live in, and give some potential options to inspire the user's answer. And the user may like a very succinct like response like San Francisco, so great. And the agent will continue to ask the second missing detail like the next question, and the user uh may sometimes like give a very long answer, long form answer, like, and especially in this kind of long form answer, it may not only answer the agent's query, but the user sometimes may give some new information. So for this new information, we also want it to be explicitly included in the assistant's explicit intention summary at the very end. So you can see like from the bottom right. So beside the two answers for each query, the agent asks like where does the user live and the criteria for the best. The user also provides some new information about what type of class actually the users want. So these new information should also be summarized explicitly in the intention summary, and uh, this will finally yield a summary. Like the user wants to find a five-star hot yoga class in San Francisco. So this is the final task version that the user actually wants. So, and also we can see this is much more clearer than the initial version. And okay, so uh, we are kind of using the annotation and many these tricks in order to construct the conversation record. And we can see from here, we call the user like user GPT, and we also use like assistant GPT. So these conversation trajectories are simulated using two different GPT models. So we definitely do not like involve so much human work, like let the human really answer these questions. So we ask the GPT model to simulate the user to give the answer like in diverse tones, and we try to record the user GPT and our assistant GPT's interaction and turn it into the trajectory that can be used for training. So here's the training. So that entails many like details like hyperparameters or things. So you can refer like to our paper for more details about this, like how we apply the conversation record and how we fit it into a template. I think there's a template here. Yeah. So this is the training template. So that's how we fit the conversation record um, into the template in order to train the instruction model. Like the for the first round, what are the initial thought, the inquiry thought, and user response. And middle round, there are like many middle rounds. Like for each round, we will entail the agent will have like an inquiry thought, like um, what should I ask next, and what I have got uh, currently. So this explicit thought will promote the agent to better reasoning and understand user intent and reasoning about what should I do next. So that is like fitting the previous conversation record into a template. So after training, we can finally conduct the experiments. So uh, we empirically trained the mistral interact model, and we wanted it to be tested through two parts. Like what I previously said during the introduction, we want evaluation to be on both instruction understanding and uh, and also instruction execution. So we divide our experiment section also into these two parts correspondingly. So first, we will evaluate on the instruction understanding. That is to directly evaluate the model's ability, like to discern what task is vague and to see whether the model can precisely capture the missing details in some vague tasks. So these are the like abilities that we explicitly want the agent to be capable of. And so during evaluation on instruction execution in the following, we test whether the real-world agent system can do the task in a better, faster, and more efficient way after like incorporating our module incorporating our trained system as an upstream module. So this entails like we first use our module to interact with the user and get a clearer version of the task. And then we use the real world like task executing agent. So in our experiment, we use X agent to carry out this task and we see whether the carry out task can be done in a more efficient way. So this will implicitly reflect that our upstream module is useful. Yeah. So these are like the mainly two parts and why we have these two parts to validate our design. So for the first instruction understanding part, we test on the test split of the iron-3 agent task, and we let the our trained model to engage in the open-ended conversation, and we record the conversation process and evaluate on the ground truth provided in the IN3. So we evaluate whether all these missing details are encompassed, like, or asked by the agent during the whole interaction process. So and we include some different baselines like we previously tested models, and we give actually a more quantitative result here. So in order to give the quantitative result, we have to design some main metrics. So this task is not like other task that measures the correctness, like or there is like a ground truth answer for you to match. Uh, no. So for this task, we actually evaluate on some aspects that we care most about. The first thing is the vagueness judgment accuracy. So this means whether the model can discern that the task is vague or not. So because in our test set, during our data construction, we construct both the clear and vague task. So the model have to discern a little bit about it. And the second point is the missing details recovery rate. So this is can be understand just from like the meaning of these words. So it means whether the model can recover the missing detail if the task is vague. And the third is the summary intention coverage rate. So this means whether all the user set intentions are explicitly summarized in the last sentence that the agent gives. So we want the agent to have this ability because the summarized intention and the summarized final task will later help the downstream task execution agent to really carry out this task. So we definitely want like an upper stream module to have this kind of ability to summarize all of it into a clearer task. So because we want the agent model to have these three abilities, so we exactly like tailor the three main metrics related to these, respectively related to these three capabilities. And there are some like other auxiliary metrics. So, but we won't talk about it in detail maybe in this presentation. So you can check the definition maybe offline through our papers. Like we include more like options presenting rate, like the average number of provided options. So some of them are not metrics. Some of them are like mainly statistics to show our model's effectiveness. Okay, so here's the main results table. So for our trained model compared with like previous open source and closed source model, we can see our model can actually achieve higher weakness judgment accuracy and can definitely recover like more missing details and give like comprehensive summary. So this is mainly compared to like previous open source models. Like we have like a huge rocketed performance compared with the model without this training, and our model's performances kind of can compete with the at that time GPT-4 model, which is like very capable model. And okay, here is like to give a clearer version of these details. So our trained model is better at understanding the user judgment. So this can be seen like we have higher weakness judgment accuracy, and also our missing detail recovery rate is kind of competitive, like can compete with GPT-4 model. And we have more comprehensive summarization of user intent. And yeah, also here we kind of highlight the average conversation rounds. So uh, this actually means our model can engage in like more rounds of interaction with the user in order to clarify their intent. And also, so the logic is like even though we have more rounds, like there are on average like over 4 rounds of interaction, we can still like let the our agent model to summarize all of these things the user said in a succinct way. And we have like enhanced model user interaction because like we give more like options and the options are reasonable and the average inquired missing detail per round. So uh, in the training data, we only let the agent model to ask one question per round with options in order to enhance the robustness and the user friendliness. And so we can see here, during our inference time, the average inquired missing details per round is also lower for Mistral Interact model. And so what this means is that the agent model does not just throw a bunch of queries directly to you. It asks the query one by one and inspire the user to answer it. So this won't like bother the user like to get the user kind of overload cognitively. So we actually design it in a more user-friendly way. And this design is actually through the training data we construct. We want the model to present some specific behaviors. And the final thing is our performance is comparable with the GPT-4 model. Okay, so here are some like cases we present through our Mistral Interact model. Like here, on the left, so the user asks like to set up a study plan for my upcoming law school exam. So we can see the analysis here is like the even though there are some misspelling, the our agent can still tackle it. And even though there are some like angry replies, our model is also can robustly solve this kind of things. So through very polite, in a very polite and robust way. And on the right, we show if the user is not cooperating, so like it doesn't matter. So the agent model will just reply. So this kind of replies are not specific for the user replies. So the Mistral Interact, this kind of model, can still like query based on the not specific reply and adapt to the user's style of like how they convey things and adaptively like change their strategy about like what to ask and how to deal with different situations. So this is one like we want to show the robustness of two varied user tones and conversation styles. And there are like more case studies. So yeah, so like the our agent it can tackle the useless replies, and our agent can like successfully summarize the additional information the user provides. So for more details, maybe you can refer to the appendix and refer to the main text also in our paper. So we will come to the next evaluation part. So after evaluated on the instruction flow, instruction understanding, we now test on the model's instruction execution ability. So as I have just said, this involves we have a real world task execution agent. And here in the experiment, we use the X agent. So it's kind of a task solving agent that can help people to automate some tasks like searching online using the tools. We want to see that if the real world agent, like X agent, they incorporate our trained module, whether the agent task can be carried out in a more efficient way. So still we use we sample 10 tasks from the test split of the IN3, and these 10 tasks are regarded as vague and they are within the X agent's ability. So and also we is extract the initial vague task description and the summary with clear user intentions. So because in the experiments we want to do a comparison. So that's why we have like for the same task, we have two different versions, and we send both these two versions to the downstream agent. So here is the X agent for execution. And the X agent here is actually powered by the GPT-4 model for planning and execution that is like carry out the task. And the X agent we have here can do web searching, code execution, command line operation, and file operating on the file system, things like that. So it's a very capable and complex agent system for task solving. And this is how we measure, like we measure the mainly through three metrics. That is all evaluated by the human. So because like uh we initially have a very vague task, and through the agent user interaction, the agent will get a clearer version of the task. So in this process, there's a user, right? So we actually recruit the undergrad, the CS student to do this, and we also ask them to evaluate the results uh, get by the X agent, whether they are satisfactory or not. And this is mainly through like the following three metrics. The first one is unnecessary subtasks or milestones. So why we have subtask or milestone is like in the X agent system, when they are carrying out an agent task, they will do something like divide and conquer. They will first divide the task into several subtasks and conquer them one by one. So this rate actually measures whether some of the subtasks they are unnecessary or the user, this undergrad student is saying that. So the agent do not have to do this in order to achieve my requirement. And the second thing is like whether each subtask is general or not. We also let the annotators, so these users, to evaluate. And for the third thing, it's kind of a objective metric that is like the two invocation times per subtask. So we want to see whether incorporating our trained model as an upper module of the complex agent system, the two invocation number can decrease. And from the result, we can see like uh, so the unnecessary subtask and the milestone number significantly decreases, and also the two general subtasks like this number also significantly decreases. And for the two invocations per subtask, we can see the number also decreases. That means like uh, so with the clearer task goal, the X agent downstream agent that carry out this task, um, they do not need to invocate the tool so much times in order to fulfill the user's needs. So that means like tools invocation numbers here actually decreases. And this reflects the effectiveness of our trained upper stream module. And here is an example to more uh, that can like illustrate it in more details. So it's like the user initially have a vague user goal, and during the interaction, intention understanding that that entails the interaction between our like recruited undergrad student and also the Mistral Interact Act agent. The Mistral Interact may finally give a summary with specific user intention that is a clearer version of the task. And we send both tasks to the downstream X agent for execution that is on the right. So for X agent to execute this task, it will first divide the task into like several subtasks and do it one by one. And for each subtask, they have like different milestones to achieve. So that's why we have like subtasks and milestones in our previous metrics. So during the execution, this entails like the X agent invocating the tools in order to solve this task. And we can see like from the case here, uh, if the user's vague user goal is directly carried out by the X agent, this may entails like the substone or milestone, subtask or milestone are too general and not focusing on what the user really wants. And also some subtasks and milestones that are not necessary. So these are some of the problems associated with like also with the X agent. So if they are not incorporating our module, they will do some useless tasks. So this will lower the effectiveness and also the efficiency of the agent system. But with our trained module as an upper stream, the X agent can carry out the task in a more targeted, user-specific way and target what the user really needs. So here's the final conclusion. Here are some thoughts and discussion. Like we also discussed in the paper. Uh, we should like more encourage the incorporation of model user interaction in the agent scenario, in order to let the agent task execution to be more robust and can satisfy the user needs. And also we discussed like how can we assess the model user interaction. So currently assessment, even though we have some like objective metrics, but you can see like through the instruction execution side, we still rely on some like user annotations, and this may not scale very well. So we also hope like future works and research could conduct more uh like detail we could give like more detailed quantitative and also automated evaluation metrics that can measure the model user interaction. And the final thing is like employing language models to emulate a user. So this is what we have done during our data creation part. So when we are creating our data, we let the GPT model to simulate the user. And we can see through our instructions, it can actually simulate diverse user tones. And we kind of validate the GPT model currently, they have this kind of ability to simulate the user. So yeah, so it's like in future research works, we may still like explore better ways for the open or closed source language model to simulate the user to collect the data, and we also encourage like more detailed investigation into how to more flexibly leverage the model's this kind of ability. So finally, here are like some listed contributions like uh, we introduce a new research question that is like the enhancement of user-agent interaction in this work. And we release the Iron 3 benchmark, which focuses on the user participation within current agent design. And we give a new mechanism and paradigm to enhance the user-agent interaction. That is like to integrate an expert specialized module in interaction. So this is also what we do. And during the evaluation, we integrate our trained model into the upper stream of an X agent, the complex system. So this means like through our method, our trained model can actually adapt to like many different complex agent system as the upper stream model. So this will make the downstream agent task be carried out in a more efficient way. And we release our Mistral Interact model, which is powerful and specialized in user-agent interaction. And we release a set of new metrics that focuses on the instruction understanding and instruction execution. Okay, so that's the final page. Like here are some of our contributions, the links to it. And if you are interested in reading more about the paper, you can scan the QR code on the bottom right.